In this video, I'm going to show you guys how to convert from degrees to radians and from radians to degrees so that you can better use the unit circle. But to start, I'm going to illustrate a simple example that you all understand, because a lot of people don't really understand that degrees and radians can be the same exact thing. So, let's start. Let's say I have $2. Well, I can have either two whole dollar bills, two whole dollar bills, that'll get me $2, or I can have 20 dimes to get me $2, or I can have 40 nickels, or I can have 200 pennies. Now, all four of these still give me the same amount of money. I still have $2 no matter what kind of unit I have. If I have 200 pennies, then I still have $2. If I have 20 dimes, I still have $2. 40 nickels, I still have $2. Because they're all the exact same. I could have a $2 bill, you know, they're all the exact same, they just have different units. So that's exactly what we're going to be doing with radians and degrees. While they seem different, they're still the same exact thing, just with a different unit attached to them. Okay, so to begin, let's do degrees to radians. So when I multiply to get degrees to radians, I multiply by pi over 180 degrees, or 2 pi all over 360 degrees. So these two fractions are the exact same. Our second fraction is just multiplied by 2 over 2. I generally tend to prefer pi over 180 because it's smaller numbers, opposed to 2 pi over 360, but you can use either one, whatever you're comfortable with or whatever you were taught in class, and you'll still get the same exact answer. So to start, I'm just going to choose 30 degrees. Generally the first little triangle on our unit circle, so that's what I'll choose. So 30 is actually 30 over 1, because remember, whenever we're multiplying fractions, if there's not a fraction specified, we're getting divided by 1. So we just have 30 over 1. And we're going to multiply this by pi over 180 degrees. You know that you've chosen the right fraction from converting degrees to radians if our two degree symbols will cancel. In this case, we have two different degree symbols, and they're going to go away. So we get 30 pi over 180, just multiplying straight across on the top and straight across on the bottom. So I'm going to build a factor tree so that I can simplify my fraction for each my 30 and my 180. So 30 is 3 times 10, and that'll get me 30, and 180 is 10 times 18, multiplying straight across, I'll get 180, or 6 times 3 times 10, multiplying straight across again, I'll still get 180. So I can see that I have a 10 and a 10 and a 3 and a 3, and the only spot that they differ is this 6 right here. So I'm just going to rewrite my fraction so that I can see each one of my multiples. So this is 3 times 10 times pi all over 3 times 10 times 6. So we can see here that our 3's are going to cancel and our 10's are going to cancel, and we're just going to be left with pi over 6 as our final angle. So we can see that 30 degrees is equal to pi over 6 radians. So similarly, down here I'm going to do radians to degrees. And all we have to do is flip our fraction from up here in order to get from radians to degrees. So it's 180 degrees over pi, which is the same as 360 degrees, all over 2 pi. So I'm going to choose the same exact angle so that you can compare the two and see how they're the same and see how they're different. So we'll choose pi over 6 as our radian degree, and then we're going to convert that into regular degrees. So because this is already in a fractional form, an obvious fractional form, then I'm just going to multiply it by 180 degrees all over pi. And we know that we've chosen the right fraction when we only have one degree symbol in our entire expression, right here. When we're converting from radians to degrees, we're only going to have 1 degree symbol, but when we're converting from degrees to radians, we're going to end up with 2 until they cancel. So here we only have 1, so we know that we chose the right conversion fraction. Multiplying straight across, I get 180 degrees times pi all over 6 times pi. So we can see here that our 2 pi's are going to cancel, and we're just going to get 180 degrees divided by 6. Well, we built a factor tree up here, and we see that 10 times 6 times 3 is going to be equal to 180. So I'm just going to rewrite that right on top. So we have 10 times 6 times 3. That'll give me 180 degrees. And here's our degree symbol. You can put your numbers in parentheses if you prefer, so that you don't have to worry about which number you're attaching your degree symbol to. All divided by 6. Well, our 6's are going to cancel out, and we're going to get 10 times 3 degrees all over 1. So, bringing that back down here, that's just going to be 30 degrees over 1, which is equal to 30 degrees. So, we can clearly see that 30 degrees is equal to pi over 6 radians, once again. So now you can see how each one of these is going to be the same and going to be different. They're just going to be slightly different because we're changing our fractional form. So, yeah, you can do this with any kind of degree and any kind of radian you can possibly imagine, so long as you choose the correct fraction to do the conversion with.